October 29th, 2025, 2:47 p.m. Moscow time. At this exact moment, something crossed an invisible line, the closest point to our sun. Distance, 204 million kilometers. This wasn't just a comet. This was an object whispered about in observatory corridors, one that made scientists peer through telescopes night after night, one that some called a messenger, and others simply an anomaly. 3I Atlas reached perihelion, and at that moment, its surface was hit by 7 to 70 watts of solar energy per square meter, a temperature capable of incinerating a fragile icy structure or, as some hoped, revealing something entirely different. Drop a comment telling me where you're watching this from and what time it is, because the story I'm about to tell requires your full attention. Let's start from the very beginning. July 1st, 2025. Chile, the High-Altitude Atlas Observatory, Asteroid Terrestrial Impact Last Alert System, a telescope designed to hunt for asteroids threatening Earth. A routine night, a routine sky scan, and suddenly, a point of light where there shouldn't be one. At first, they thought it was an error. Then the checks began. Motion, trajectory, spectral analysis. What the astronomers saw made them freeze. The object wasn't moving like an asteroid from the belt, not like a comet from the Oort cloud. Its orbit was hyperbolic. It came from interstellar space, the third confirmed interstellar visitor in human history, after Oumuamua and Comet Borisov. Now, 3I Atlas. But there was something more. The comet's shape turned out to be elongated, stretched out. A green coma enveloped the nucleus, a sign of cyanogen and diatomic carbon evaporating under sunlight, a color that in ancient times was called a harbinger of disaster, and in the 21st century became simply an indicator of chemical composition. Or was it something else? Astronomers began tracking the object around the clock. Every observatory with access to the southern hemisphere pointed its instruments at this moving dot. Data poured in from around the world. Brightness, spectrum, velocity. And with each passing day, 3I Atlas drew closer to the sun, and with each passing day, the questions multiplied. Avi Loeb, professor of astronomy at Harvard University, a man unafraid to say what others preferred to keep silent about. After the discovery of Oumuamua, he was one of the few who openly suggested, perhaps we saw a technological artifact, a solar sail from an alien civilization. His colleagues shook their heads, called it speculation. But Loeb kept insisting, science must consider all hypotheses, including the boldest ones. And now, looking at 3I Atlas, he spoke up again. He called perihelion the acid test, the moment of truth. If this is a natural comet held together by weak forces, frozen water and gases, then the heating should destroy it. Fragmentation, debris, a sharp release of gas and dust, a bright flash in telescopes, and then disintegration into multiple smaller fragments that would evaporate faster due to increased surface area. But what if it's not a comet? What if something artificial is hiding beneath that greenish coma? A structure capable of withstanding 770 watts per square meter? Then we might see maneuvers, trajectory changes without apparent cause, deployment of mini-probes, artificial lighting, excess thermal radiation inconsistent with solar heating. Loeb knew most scientists would consider this fantasy, but he also knew that science only moves forward when it asks uncomfortable questions. And the question about 3I Atlas was the most uncomfortable of all. Are we alone in the universe? The weeks before perihelion were filled with intense anticipation. Spacecraft redirected their cameras. GOES-19, a weather satellite in geostationary orbit, received orders to monitor the region of sky where the comet was due to pass. SOHO, Solar and Heliospheric Observatory, a veteran of space observations flying since 1995, aimed its LASCO C3 coronagraph at the approaching object. Stereo A, a solar observatory drifting ahead of Earth in its orbit, deployed its HI-1 and QR-2 instruments. Even spacecraft at Mars, Mars Express and ExoMars TGO, got a unique opportunity to observe the comet from a different vantage point, creating a stereoscopic vision effect for the entire solar system. October 28th, one day before perihelion, a paper with preliminary data appeared on the Archive server. Astronomers who'd been tracking 3I Atlas for the past months published their brightness measurements. The graph showed something disturbing. The comet's brightness was growing at a rate proportional to r to the power of -7.5, plus or minus 1. For those who don't speak the language of celestial mechanics math, let me translate. This is several times faster than normal comets. A typical comet increases brightness at a rate of r to the power of -2, sometimes -4. But -7.5? This meant unusually active gas release. Possible outbursts, as astronomers call them. Sharp, sporadic ejections of material, or something else. The paper provided no answers, just facts. But these facts didn't fit conventional models. The final hours before perihelion, the CCR-1 coronagraph captured 3I Atlas as an extended source. The coma, a cloud of gas and dust around the nucleus, stretched for 4 arc minutes. On Earth's sky, that's about 1/8 of the full moon's diameter. Seems small? But consider, the comet was 204 million kilometers away. The real size of the coma, hundreds of thousands of kilometers, a gas shell glowing from solar radiation, shrouding an invisible nucleus, and the color of this coma turned out strange. Color photometry showed that 3I Atlas was noticeably bluer than the sun. Comets usually reflect sunlight and have a similar spectrum, but here, a significant portion of the brightness came from gas emissions, the glow of atoms and molecules excited by ultraviolet light, a bluish tint. Green coma. The comet was glowing not just with reflected light, but with its own fluorescent radiation. And then came the moment of truth. 11:47 UTC, 2:47 p.m. in Moscow, perihelion. 3I Atlas reached its closest point to the Sun, 136 astronomical units, a bit farther than Mars's orbit, but still in the zone of intense solar radiation. Spacecraft cameras were aimed. Detectors recorded every photon. On Earth, astronomers stared at monitor screens, refreshing data in real time. What did they see? The comet passed perihelion. It didn't disintegrate, didn't fragment. Brightness continued to increase, but there was no catastrophic ejection that would be expected from a disintegrating icy body. The green coma still enveloped the nucleus. The object continued moving along its hyperbolic trajectory, heading back into interstellar space. October 30th, the next day, the first 24 hours after the test. Data began flooding into research centers, high-resolution images, spectral measurements, thermal maps. Scientists analyzed every pixel, every spectral line. Preliminary conclusions were cautious. 3I Atlas survived perihelion, structural integrity maintained, coma stable, but the unusual rate of brightness increase demanded explanation. Activity bursts? Specific composition of ices with low sublimation temperature? Or still? But let's pause here for a moment. Because before moving forward, we need to understand what exactly makes 3I Atlas so special. Why does one comet attract so much attention when dozens of new comets are discovered every year? It's not just the interstellar origin, It's the combination of anomalies: elongated shape like Oumuamua, unusual brightness growth, stability passing through perihelion. All of this taken together formed a picture that didn't fit standard models, and the more data came in, the more questions arose. Mars Express, a European spacecraft orbiting the red planet since 2003. 22 years of continuous operation. The HRSC high-resolution camera created for mapping the Martian surface, and suddenly, a new task. On October 1st, 2025, the spacecraft received a command: turn cameras away from Mars, into deep space, where a green dot was moving. ExoMars Trace Gas Orbiter, Mars Express's younger brother, operating in orbit since 2016, joined the observations. Its CAS's camera and Nomad spectrometer were ready. October 3rd, closest approach. 3i Atlas passed 30 million kilometers from Mars. For cosmic scales, practically next door. Front row seats, images began arriving on Earth. ExoMars TGO used 5-second exposures, long light accumulation to capture a faint object against the starry sky. In the images, the comet looked like a blurry white spot, slowly shifting between frames. A nucleus shrouded in a coma, a hazy shell of gas and dust stretching for hundreds of thousands of kilometers. Mars Express faced a problem. Its camera's maximum exposure was only half a second. Too little for such a dim object. Initial detection attempts yielded no results. The comet remained invisible in the image noise, but scientists didn't give up. They began stacking multiple images together, averaging out the noise and amplifying the weak signal. A method known to astronomers since the 19th century, now applied to an interstellar visitor in the 21st. But the main goal wasn't just to see the comet. They needed to understand its chemical composition. The Omega and SpyCam spectrometers aboard Mars Express, Nomad on ExoMars TGO, all were pointed at 3i Atlas. Spectroscopy, a method of breaking down light into components, like a prism splitting white light into a rainbow. Every atom, every molecule absorbs and emits light at strictly defined wavelengths. Hydrogen glows in red, oxygen in green. Carbon creates a whole set of lines. By analyzing the comet's spectrum, you can determine what its gas shell is made of. It's like a chemical fingerprint. And 3i Atlas's fingerprint turned out unusual. August 6th, 2025. Long before perihelion, when the comet was at a distance of 3.32 astronomical units from the Sun, nearly Jupiter's orbit, the James Webb Space Telescope aimed its NIR-SPEC infrared spectrograph at the interstellar guest, the most powerful telescope ever sent into space. A 6-meter mirror cooled to minus 223 degrees Celsius. The ability to see in the infrared range allowed detection of molecules invisible in ordinary light. Data arrived on Earth within hours, and when astronomers deciphered the spectra, they saw something that made them reconsider all assumptions about 3i Atlas's nature. Carbon dioxide, CO2. It dominated the comet's coma. The ratio of carbon dioxide to water was 8:1. For comparison, typical solar system comets have the opposite ratio: more water, less CO2. Halley's Comet, the most famous periodic comet, releases mainly water vapor. Even Comet Borisov, the second confirmed interstellar object, showed a more familiar chemical profile. But 3i Atlas was different, 8:1, one of the highest CO2-H2O ratios ever recorded for a comet. Why? There was another detail. Besides carbon dioxide and water, spectrometers detected carbon monoxide, 9% by mass, carbonyl sulfide, OCS, water ice, dust, a whole cocktail of chemical compounds. But it was the dominance of CO2 that gave no peace. One theory suggested that 3I Atlas formed close to the carbon dioxide ice line in its parent star's protoplanetary disk. In that zone where temperature was low enough for CO2 to freeze, but too warm to capture large amounts of water. Another theory spoke of thermal processing. Perhaps the comet spent a long time near its star before being ejected into interstellar space. Heating evaporated volatile substances, carbon monoxide, which sublimes at lower temperatures, leaving predominantly water and CO2. But there was a third, more exotic idea. 7 billion years. That's how long, by some estimates, 3I Atlas could have drifted in interstellar space. Temperature close to absolute zero. Constant bombardment by cosmic rays. High-energy particles permeating the galaxy. This radiation could cook the comet's surface, creating a crust of processed materials. CO2 could form right on the surface due to radiolysis, the splitting of molecules by radiation with subsequent synthesis of new compounds. When the comet approached the sun and the surface began heating, this excess carbon dioxide started evaporating. Heat couldn't penetrate deep into the nucleus due to ice's low thermal conductivity, so water buried deeper remained frozen. Result: high CO2-H2O ratio. And then there was the color. Green. An emerald halo around the comet. Astronomers knew the cause. Diatomic carbon, C2. A molecule of two carbon atoms bonded together. When solar ultraviolet hits these molecules, they fluoresce, emitting green light at a wavelength of 517 nanometers. A classic sign of cometary activity. But where did C2 come from? Probably from the breakdown of more complex organic compounds, hydrocarbons located in the comet's nucleus. Solar radiation destroyed these molecules, and among the breakdown products was diatomic carbon. Interestingly, in August, when the comet was farther from the sun, C2 wasn't detected. The green coma appeared later, when heating intensified. This suggested that the comet's inner layers, containing organics, began opening up as surface ice evaporated. October 28th, one day before perihelion. A paper on Arxiv, the preprint archive for scientific work. A team of astronomers published observation data of 3I Atlas from 4 space observatories. Stereo A observed the comet from September 11th to 26th with HI-1 and Core 2 instruments. SOHO LASCO C3 tracked it from October 15th to 26th. GOES 19 CCOR-1 from the 18th to 24th. Each instrument worked in its own spectral range. Each recorded brightness changes from different angles. Combined data showed a brightness growth graph, and the slope of this graph was disturbing. A power law dependence of R to the minus 7.5, 3 to 4 times steeper than normal comets. What did this mean? Either extremely active degassing, or a series of outbursts, or something scientists didn't yet understand. Color photometry added another puzzle. The comet was noticeably bluer than the sun. Normal comets reflecting sunlight have a spectrum close to solar, slightly reddish due to dust, but 3I Atlas glowed blue. This indicated that a significant portion of visible light came not from reflection, but from gas emission. Atoms and molecules in the coma, excited by ultraviolet, emitted their own light, blue and green hues. The comet wasn't just reflecting the sun. It glowed from within, like a giant fluorescent lamp in space. And all this time, the comet approached the moment of truth. October 29th, 1147 UTC, perihelion. But for observers on Earth, this was a moment of blindness. The comet was behind the sun. Solar conjunction occurred on October 21st, 8 days before perihelion. Angular distance from the sun dropped below 30 degrees. No ground-based telescope could see it. The blinding light of the day star made observations impossible. Only space coronagraphs, blocking direct sunlight with an artificial disk, could track the comet. And Mars Express and ExoMars TGO at Mars and future observations from JUICE at Jupiter. But the actual moment of perihelion was hidden from human eyes on Earth. Avi Loeb waited. He knew the next days would be critical. If the comet disintegrated, observers would see a cloud of fragments when it emerged from behind the sun in early November. If it remained intact, that was already information. Integrity under such heating could indicate unusual internal structure. A monolith, a solid core, or, as he suggested in his publications, possibly something artificial, a mothership, as he called it in one interview, an object capable of releasing mini probes toward nearby planets, Mars, Venus, Jupiter. 3I Atlas's trajectory passed within tens of millions of kilometers of these worlds. The probability of such a trajectory: 0.5%. Too precise for coincidence? Or just a rare match in a huge sample of interstellar objects, most of which we'll never see? There were other oddities on Loeb's list. 8 anomalies, score 4 on his scale, where 0 is definitely a natural object and 10 is definitely technological. A trajectory within 5 degrees of the ecliptic plane, the plane in which solar system planets move. Probability for a random interstellar object, 0.2%. A solar jet, gas ejection toward the sun, observed in July and August. Usually comets eject gas away from the sun due to solar radiation pressure. But here was an anti-tail, a structure directed toward the day star, not an optical illusion, like with some comets when dust particles linger in orbit, creating the appearance of a reverse tail. Real gas ejection. Why? The object's mass, another anomaly, 33 billion tons, 1 million times heavier than Oumuamua, 1,000 times more massive than Comet Borisov. This isn't a small rock accidentally ejected from a planetary system. This is a massive body. If its density is close to water ice density, about 900 kilograms per cubic meter, then the nucleus diameter would be several kilometers. An entire ice mountain drifting between stars. But was this a mountain of ice? Or something with higher density, covered by an icy shell? Without direct measurements of nucleus size, and telescope resolution didn't allow seeing it separately from the coma, this question remained open. NASA was silent. This was another oddity Loeb noticed. The agency wasn't publishing fresh data. In one interview, Loeb mentioned a government shutdown, a halt to federal agency operations due to budget disputes. But was this the real reason? Or just the usual delay in data processing? Loeb contacted the principal investigator of one of the instruments at the University of Arizona. No response. "We can't observe it from Earth now because it's behind the sun," Loeb said. "But if it appears again, and we notice smaller objects moving toward planets, this could indicate probe release." Words that for some sounded like scientific boldness, and for others, like speculation on the edge of science fiction. But Loeb was used to criticism. After Oumuamua, his solar sail hypothesis triggered a wave of skepticism. Colleagues shook their heads. Media wrote sensational headlines, but he kept insisting. Dismissing the extraterrestrial technology hypothesis a priori is unscientific. Science requires consideration of all explanations consistent with the data, and if the data doesn't exclude artificial origin, this possibility must be studied, not as the only explanation, not as the most probable, but as one hypothesis among others. The Galileo project, which he led, was based precisely on this principle: systematic search and analysis of potential extraterrestrial artifacts using rigorous scientific methods. and 3I Atlas became another object of close attention for this project. October 30th. The first 24 hours after perihelion, data was still being processed. High-resolution images required weeks of analysis. Spectra needed calibration and interpretation, but the initial signs were clear. The comet survived perihelion. It didn't disintegrate, didn't fragment into multiple pieces. The green coma still shrouded the nucleus. The object continued moving away from the sun along its hyperbolic trajectory. In a month, at the end of November, it would become visible from Earth again, now in the morning sky before sunrise. Brightness would begin dropping as it receded. By December, the comet would pass through the constellations Virgo and Leo, fading with each day. December 19th, 2025, closest approach to Earth at a distance of about 2 astronomical units, still too far for detailed study by ground-based telescopes. And then, retreat back into interstellar darkness, forever. October 30th, 2025, morning. Space Research Institute of the Russian Academy of Sciences, Solar Astronomy Laboratory. On monitor screens, a series of images from a space coronagraph, black and white frames where the sun is covered by an artificial disk, and around it, the corona, prominences, plasma ejections, and there, among this chaos of solar activity, a tiny dot, a blurry spot, slowly shifting from frame to frame. 3I Atlas. It was intact. October 29th, 11:47 UTC, the moment of perihelion was behind it. 770 watts per square meter, a temperature capable of evaporating water ice within hours. But the comet didn't disintegrate, didn't fragment into a swarm of debris, as some models predicted. It passed through fire and remained whole. October 27th. 2 days before perihelion, the comet encountered a coronal mass ejection, a cloud of solar plasma racing into space at hundreds of kilometers per second. Millions of tons of ionized gas, heated to millions of degrees. For a fragile, icy body, such a collision could be fatal. Structural destruction, evaporation of outer layers, fragmentation. But when astronomers analyzed the data after impact, they saw the same blurry spot moving along the same trajectory. Structural integrity maintained. The object continued approaching the sun, as if the plasma test was nothing more than a light breeze. What did this say about the nucleus's nature? About its strength? About what was hiding beneath the green coma? Russian scientists compiled a video from space coronagraph data, frame-by-frame animation showing the comet's movement against the solar corona backdrop. Each frame, hours of observations. Each pixel, thousands of photons collected by the detector. And in this video, published on the laboratory's Telegram channel, it was clear. 3I Atlas moves without changing trajectory. No maneuvers, no structure deployments, no signs of active control. For some, this was relief, a natural object behaving as a natural object should. For others, disappointment. Where were the mini-probes Loeb talked about? Where were the signs of artificiality? But there were those who pointed out, absence of visible maneuvers doesn't prove natural origin. Perhaps the object is simply using the sun for a gravity assist without firing engines. Perhaps any actions are planned for later, when the comet moves away from the star. Debates continued. October 29th, perihelion day, 2:47 p.m. Moscow time. At this moment, the comet reached its closest point, 203.5 million kilometers from the sun's surface, 1.36 astronomical units. For comparison, Mars's orbit, 1.52. The comet passed deeper than the red planet, but not as deep as Earth or Venus, a zone of moderate but still intense heating, enough to evaporate volatile substances, enough to test any structure's strength. and the comet passed the test. Data from SOHO LASCO C3 showed stable brightness. The coma still shrouded the nucleus, no sharp flares indicating catastrophic disintegration. The object passed Avi Loeb's acid test. But what did this prove? Lyudmila Koshman, astronomer at the Moscow Planetarium. On October 29th, she gave an interview to RIA Novosti. Her words were cautious but informative. After October 30th and until November 17th, Comet 3I Atlas can be observed from Moscow in the morning sky for a very short time, from 5 to 7 o'clock, low above the southeastern horizon before sunrise, and only through a telescope with an objective diameter of at least 25 centimeters. The comet's brightness, plus 14.7 magnitude. For astronomers, this number meant one thing: invisible to the naked eye. Even with binoculars, chances minimal. Only a telescope, and not just any, but powerful enough, and only in a narrow window between the end of astronomical twilight and sunrise. Finding such a faint comet in the rising sunlight will be quite difficult, Koshman added. But for those wanting to see the interstellar guest with their own eyes, this was a chance. The constellation Virgo. All of November 2025, the comet will move through this section of sky. From October 30th to November 5th, it will fly near Spica, Alpha Virginis, a bright blue-white star 250 light-years away. Nearby, in the same area of sky, Venus shone, the morning star, a planet whose brightness reaches -4 magnitude, so bright it can be seen even during daytime if you know where to look. And here, against this backdrop, a dim, barely discernible point. 3I Atlas. An object that came from beyond the solar system. Strange neighbors, an ancient star, a young planet, and a 7-billion-year-old comet that drifted in interstellar darkness longer than Earth has existed. Diameter 20 kilometers. This figure appeared in several Russian sources after perihelion passage. 20 kilometers of nucleus, if density is close to ice density. For comparison, Halley's Comet has a nucleus approximately 15 by 8 kilometers. Oumuamua, no more than 400 meters long. Comet Borisov, about 1 kilometer. 3I Atlas was a giant, a massive object tens of times larger than previous interstellar visitors, 33 billion tons of material, an ice mountain the size of a small city. If this is a natural comet, then one of the largest ever observed near the Sun. If not, then the question becomes even more intriguing. 7 billion years. Age estimated based on trajectory and chemical composition analysis. This meant 3I Atlas formed even before the solar system's birth. Our Sun, a third-generation star, formed from remnants of more ancient stars about 4.6 billion years ago. And 3I Atlas was older. It was born in the Milky Way's thick disk, a region populated by ancient stars moving in elongated orbits above and below the galactic plane. Stars formed at the galaxy's dawn, when the Milky Way was younger, smaller, more chaotic. And somewhere there, in a system of one of these ancient stars, in a protoplanetary disk of gas and dust, the future comet's nucleus condensed. Frozen gases, water ice, hydrocarbons, silicates, all this compressed into a single structure. What happened next? How did 3I Atlas leave its parent system? Perhaps gravitational interaction with a gas giant, a planet the size of Jupiter or larger, ejected it onto a hyperbolic trajectory. This is a common mechanism for forming interstellar objects. Young planetary systems are full of chaos. Planets migrate, orbits intersect, small bodies scatter in all directions. Some fall onto the star. Others remain in the system, forming asteroid belts and comet clouds. And still, others receive enough energy to permanently leave their home star. And so, 7 billion years ago, 3I Atlas began its journey. Endless falling through the void. Temperature minus 270 degrees. No light except distant stars. Cosmic rays slowly bombard the surface, creating chemical reactions in frozen layers. How many star systems did it pass through during these billions of years? How close did it approach other stars? We don't know its full history. We see only the final part, entry into our solar system, trajectory with eccentricity 6.15. For comparison, eccentricity 1 means parabolic orbit, an object barely bound by the sun's gravity. Eccentricity greater than 1, hyperbolic trajectory, object not bound at all. And 6+, this means high speed. The object flies through the system, barely slowing under solar gravity. Entry velocity into the solar system, tens of kilometers per second relative to the local standard of rest, and after passing perihelion, return to the abyss at the same speed. December 19th, 2025. This date was marked on all astronomical calendars. Maximum approach to Earth. Distance, 1.8 astronomical units, about 270 million kilometers. Sounds like a lot? For cosmic scales, this is relatively close. Closer than Mars at great opposition, but still too far for detailed ground-based observations. Nucleus size, 20 kilometers at 270 million distance. This is an angular size of less than a millisecond of arc. Directly seeing the nucleus structure is impossible, even in the largest telescopes. All we see is the coma, a hazy shell of gas and dust smeared across the sky. But for spectroscopy, this isn't a problem. Analysis of light emitted by the coma can reveal chemical composition, temperature, gas outflow velocity. This data was most valuable. After December 19th, the comet will start receding. Brightness will drop proportional to the square of distance from the Sun and the square of distance from Earth. By late December, it will dim so much that it becomes accessible only to professional observatories. By January 2026, it will disappear even for them. The object will go beyond the capabilities of modern telescopes. In a year, it will leave the inner solar system. In 10 years, it will pass Neptune's orbit. And then, interstellar space again. Forever. Next close approach? Impossible to predict. Perhaps in millions of years, 3I Atlas will enter another star system. Perhaps it will collide with some planet or star. Perhaps it will drift eternally until the universe ends its existence in heat death, trillions upon trillions of years from now. But what about Avi Loeb's hypothesis? Perihelion passage didn't provide a definitive answer. The comet didn't disintegrate. That's a fact. But does this mean it's artificial? Not necessarily. There are many mechanisms capable of making a natural comet more durable. Sintered structure, ice compacted over millions of years under its own gravity, a crust of radiation-processed material on the surface, high content of refractory components, silicates, high molecular weight organics. All this could ensure structural integrity even under strong heating. On the other hand, absence of fragmentation didn't exclude technological nature either. A solid hull, thermal protection coating, internal structure capable of withstanding thermal loads. There wasn't enough data for a final conclusion. Additional observations were needed. More detailed spectroscopy, thermal emission analysis, search for non-periodic brightness changes that could indicate rotation of a non-spherical body. Mass media hyped the topic. Headlines blazed with words, alien ship, extraterrestrial technology, mothership, For many, this was a thrilling story. The possibility that somewhere out there, among the stars, intelligent life exists, and we just saw its messenger. For others, annoying speculation distracting from real science. Truth, as always, lay somewhere in the middle. Science demanded remaining open to all hypotheses while maintaining strict standards of proof. Extraordinary claims require extraordinary evidence, a principle formulated by Carl Sagan in the 20th century. And so far there was no extraordinary evidence, only intriguing anomalies, only questions yet to be answered. October 30th ended, the first day after perihelion came to a close. The comet continued moving away from the sun, heading toward the morning sky. Astronomers prepared their telescopes. Observation schedules were compiled. Spectrographs were programmed. Somewhere in orbit, spacecraft turned to catch the comet in their field of view next time. On Earth, enthusiasts checked star charts, calculated ephemerides, searched for the best observation points away from city light pollution. 3I Atlas hadn't revealed all its secrets yet. Perhaps it never will. But its very existence, an interstellar object passing through our system, was already a miracle. A reminder that space is vast, full of mysteries, and we're only beginning to understand it. October 31st, 2025. 5 a.m. Moscow region, private observatory. The dome slowly rotates, following an invisible point in the sky. Inside, a Schmidt-Cassegrain telescope. Main mirror diameter 35 centimeters. Enough for faint objects. An amateur astronomer, a retiree, former engineer who devoted the last 20 years to studying the sky, peers into the eyepiece. Southeastern horizon. Low. Too low. The atmosphere here is dense, turbulent. Light scatters on air molecules, on dust, on water vapor. And somewhere there, among this flickering chaos, should be a point. Dim, blurred. 3I Atlas. First day after perihelion, first opportunity to see it from Earth after weeks of blindness. Magnitude plus 14.7. For the uninitiated, this is just a number. For astronomers, the boundary of possibility. The naked eye sees stars down to 6th magnitude under ideal conditions. Binoculars extend this limit to 10th. An amateur telescope to 13th, maybe 14th if you're lucky with sky transparency and no light pollution. But 14.7, that's already on the edge. Now add morning twilight. The sun hasn't risen yet, but the eastern sky is already brightening. Blue hour. Astronomical twilight ends, nautical begins. The sky changes from black to dark blue. Stars fainter than 4th magnitude start getting lost in this glow. And the comet, 15 magnitudes fainter, searching for it in these conditions, like looking for a needle in a haystack where the haystack itself glows. But the astronomer knew where to look. Ephemerides, tables of celestial body positions calculated from orbital data. Stellarium software on his laptop showed the exact location. Constellation Virgo, Alpha Virginis, Spica, a bright blue-white star. Magnitude plus 10, visible even in urban conditions. Binary star system, 250 light-years away. Main star, a massive blue-white giant, 10 times heavier than the sun. Surface temperature, 22,000 degrees. Luminosity 12,000 times solar. And next to it, slightly west, Venus, the morning star, magnitude -4, so bright it casts shadows in complete darkness. A planet shrouded in a dense atmosphere of carbon dioxide and clouds of sulfuric acid. A hellish world with surface temperature 470 degrees. But from Earth, beautiful. A shining pearl on the dawn sky, somewhere between Spica and Venus, slightly north. 3I Atlas should be. The astronomer aimed the telescope at Spica, a bright point in the center of the field of view. then slowly shifted the tube 2 degrees north. Empty field. A few faint background stars. Nothing resembling a comet. He switched to a lower magnification eyepiece, widening the field of view. Scanning the area. 1 minute. 2. 3. The sky continued brightening. 5:30. The window of opportunity narrowing. Another half hour, maybe 40 minutes, and the comet would drown in morning twilight. He turned on the camera mounted in the telescope's focal plane. Long exposure. 30 seconds. 60. Light accumulation. A method used even by 20th century photographers with film cameras. But now, a digital sensor capable of registering individual photons. An image appeared on the laptop screen. Black and white, grainy. Dozens of points, stars, and one of them, not quite a point, a blurred spot, slightly elongated, coma. He compared it with the chart, coordinates matched. 3I Atlas. First personal photograph of the interstellar guest. Not as sharp as images from space telescopes, not as detailed, but his own. Made here on Earth, at 5 a.m. on a cold autumn day. Proof that somewhere there, at a distance of 200 million kilometers, an object moves that came from beyond the solar system. An object that 7 billion years ago was ejected from its home star system, and now, for a moment by cosmic standards, crosses ours. Constellation Virgo, one of the largest constellations in the sky, occupies 1,294 square degrees, third largest after Hydra and Ursa Major. In ancient Greek mythology, Virgo was associated with Astrea, goddess of justice, last to leave Earth at the end of the Golden Age, or with Demeter, goddess of fertility and agriculture, or with Persephone, Demeter's daughter, abducted by Hades to the underworld. A spring constellation by traditional calendar, but now, in late October, it appeared in the morning sky shortly before dawn, harbinger of winter. And through this constellation lay the path of 3I Atlas. All of November, slow movement west to east relative to background stars, about 2 degrees per day, speed noticeable even within a single night of observations. Spica lay almost exactly on the ecliptic, the imaginary line in the sky along which the sun moves throughout the year. More precisely, it's the projection of Earth's orbital plane onto the celestial sphere. Planets also move near the ecliptic because they all orbit roughly in one plane, a relic of the primordial protoplanetary disk from which they formed 4.5 billion years ago. And 3I Atlas's trajectory also lay close to this plane. Orbital inclination, just 5 degrees to the ecliptic. For a random interstellar object, this is unusual. Probability of such orientation, fractions of a percent. Objects coming from interstellar space can have any inclination, from 0 to 180 degrees. But 3I Atlas seemed to deliberately choose the plane of planets. Coincidence, or hint at something more? November 2nd. The astronomer returned to the observatory. Again 5 a.m. Again the same area of sky. But the comet had moved. Now it was farther from Spica, moving north and east. Brightness remained about the same. A small change in Earth distance hadn't noticeably affected it yet. He made a new series of images, 30 frames of 60 seconds each, then stacked them together using specialized software. Stacking, a method of summing multiple images to increase signal-to-noise ratio. Random noise averages out and weakens. Signal from the comet accumulates and strengthens. The resulting image was sharper, coma visible more clearly, a faint hint of tail, direction away from the sun, dust and gas ejected from the nucleus, pushed by solar wind and radiation pressure. Classic cometary feature, proof of activity. He measured the coma's brightness using aperture photometry, virtual circle around the coma center, summing all pixels inside, subtracting background. Result, plus 14.8 magnitude. Slightly fainter than predicted. Perhaps activity declining after perihelion. Perhaps just measurement inaccuracy due to low altitude above horizon. Or maybe the comet really was starting to dim faster than expected. That would be interesting. Rapid fading would indicate depletion of volatile substances in the nucleus's surface layers. Once the ice reservoir on the illuminated side is exhausted, degassing slows. The nucleus covers itself with a crust of refractory residues, dust, organics, minerals. This crust insulates inner layers, preventing further evaporation. The comet falls asleep. But there were others observing 3I Atlas in these days, professional observatories, Pan-STARRS telescope in Hawaii, VLT survey telescope in Chile. Hubble Space Telescope got observation time in early November. Its Wide Field Camera 3 was pointed at the sky area where the comet was moving. Series of high-resolution images. The goal was to try resolving the coma structure. Sea-jets directed gas emissions from active regions on the nucleus surface. Detect possible fragments if the nucleus did crack during perihelion. Measure precise coma size and shape to estimate gas and dust production rate. Data should arrive within days after observations. Preliminary processing, calibration, removing cosmic rays and other artifacts. Then, publication in the telescope archive for the scientific community. November 5th. The comet passed the point of maximum approach to Spica. Distance in the sky, about 1 degree. That's 2 full moon diameters. Visually close. Physically, a chasm. Spica was 250 light-years away. 3I Atlas, some 200 million kilometers. Difference by trillions of times. But for an Earth observer, they shared the same small patch of sky. Random alignment, optical conjunction, convenient landmark for finding the comet. Find Spica, shift 1 degree north. Such instructions were published on astronomy forums and amateur observation groups. Hundreds of people worldwide aimed their telescopes at this area. Not everyone found the comet. Its faintness required experience, good equipment, and dark sky. But those who found it shared images online. The collection of images grew. Venus also served as a landmark, the brightest object in the morning sky after the moon. Impossible to miss. By early November, it was about 10 degrees west of Spica, angular distance roughly equal to the width of a fist at arm's length. 3I Atlas passed between them. Triangle in the sky, Venus, Spica, comet. One amateur astronomer created a wide-angle photograph capturing all 3 objects. Venus, blindingly bright. Spica, a noticeable point. And between them, barely discernible even on long exposure, a blurred speck of the comet. The image got thousands of views on social media. Comments divided. Some admired the rare opportunity to see an interstellar object. Others mocked conspiracy theorists. Still others kept insisting on 3I Atlas's artificial nature. Debates didn't subside. On Reddit, in our astronomy and our space communities, endless discussions raged. Some users cited scientific papers explaining all observed anomalies by natural processes. High CO2-H2O ratio, thermal history and radiation processing, unusual brightness, activity bursts due to heterogeneous nucleus composition, flat orbit, statistical coincidence. We see one object but miss thousands of others with different inclinations because they're too dim for detection. Others pointed to Avi Loeb's 8 anomalies, claiming the probability of all these coincidences was too small for a natural object. Trajectory passing near Mars, Venus, Jupiter. Solar jet directed toward the sun. Object's massiveness. structural integrity after perihelion. All this added up to a picture that made you think. November 10th, the comet continued moving through Virgo, brightness slowly dropping, plus 15.0 magnitude, even fainter. Observing became harder, required larger telescopes, longer exposures, more careful data processing. Many amateurs stopped trying. The object became too challenging for their equipment. But professionals continued. Spectroscopic observations with VLT's 8-meter telescopes, analysis of emission lines in ultraviolet using Swift Space Telescope, infrared measurements with Spitzer Telescope, a veteran operating in warm mode after exhausting liquid helium supplies for cooling. Each instrument added a piece of information to the overall mosaic. Chemical composition data was being refined. Besides dominant CO2, spectrometers detected traces of other molecules: ammonia, NH3, methane, CH4, ethane, C2H6, formaldehyde, H2CO, hydrogen cyanide, HCN, the whole set of organic and inorganic compounds typical of comets. But ratios were unusual. High content of nitrogen-containing compounds, low content of simple hydrocarbons. What did this say about formation conditions? About temperature and pressure in the protoplanetary disk of the comet's home system? About the star around which it formed? Scientists built models trying to recreate the object's history. Computer simulations of chemical processes in early planetary systems. Comparison with solar system comets and with Comet Borisov. Gradually, a picture emerged. 3I Atlas most likely formed in a system of a K or M-class star, a red or orange dwarf, cooler and dimmer than our Sun. Such stars constitute the majority in the galaxy. About 70% of all stars. Their planetary systems have narrower habitable zones, shifted closer to the star, the region where temperature allows liquid water to exist on a planet's surface. But farther from the star, in cold outer regions, comets form. And the chemical composition of these comets depends on the star's spectrum. Red dwarfs emit less ultraviolet, which affects photochemical reactions in the protoplanetary disk. More complex organic molecules can survive without destruction. More nitrogen-containing compounds get incorporated into ice grains. Result: a comet with a unique chemical fingerprint. November 17th, last day of the observation window from Moscow, according to Lyudmila Koshman from the Moscow Planetarium. After this, the comet rose higher in the morning sky but simultaneously dimmed rapidly. Magnitude dropped to plus 15.5, the limit of most amateur instruments. From November 18th onward, only large professional telescopes, only specialized observation programs. For the general public, the show was over. 3I Atlas again became an object accessible only to the few. But the story continued, because December lay ahead. Passage through the constellation, Leo, the 19th. Maximum approach to Earth. Last chance to study the interstellar guest before its departure into eternal darkness. November 20th, 2025. Harvard-Smithsonian Center for Astrophysics, Cambridge, Massachusetts. Avi Loeb's office. On the wall, photographs of galaxies, nebulae, star clusters. On the desk, stacks of scientific papers, data printouts, brightness graphs. Loeb was studying the latest images from Hubble Space Telescope, images obtained a week ago when 3I Atlas was still bright enough for detailed analysis. He searched for what others might have missed: anomalies, inconsistencies, signs that the object was something more than just an icy chunk from interstellar space. His fingers glided across the keyboard, zooming into the coma image, pixel by pixel, searching for jets, directed gas emissions, searching for asymmetry that could indicate rotation of a non-spherical body, searching for any hint of structure within the hazy shell. The data was ambiguous. The coma appeared relatively symmetrical, round, blurred, without obvious jets or emissions. This could mean two things. Either the nucleus was degassing uniformly from its entire surface, which is unusual for comets. Typically, only certain areas illuminated by the sun are active, or we were seeing the object during low activity, when intense emissions had already ceased after perihelion passage. Surface temperature was dropping as it receded from the sun. Evaporation slowing. The coma created during maximum heating was now dispersing into space, inflated by solar wind, and new material was arriving slower and slower. In a few weeks, degassing could completely stop, and the comet would become a dark, inert object, indistinguishable from an asteroid, except for its hyperbolic trajectory. Loeb pondered the 8 anomalies, his list, which he publicly voiced in interviews and articles. Trajectory within 5 degrees of the ecliptic, flyby near several planets, solar jet directed toward the sun, high mass, unusual brightness growth, structural integrity after perihelion, chemical composition dominated by CO2. Each anomaly separately could have a natural explanation, but all together, the probability of such a combination was low, not zero. Statistics allowed for rare coincidences, but low enough to consider an alternative hypothesis. A hypothesis that made many of his colleagues wince. Artificial origin, not in the sense of built by humans, in the sense of built by someone. A probe, a ship, a device of unknown purpose, an artifact of extraterrestrial technology. Critics were merciless. At conferences, in hallways, on social media. Loeb added again, aliens everywhere. Oumuamua, a ship. 3I Atlas, a ship. The next comet will be a ship too. Accusations of sensationalism, of trying to attract media attention, of departing from rigorous scientific methodology. But Loeb didn't back down. He pointed to the history of science. How many times were new discoveries met with skepticism and mockery? Meteorites, rocks from the sky, were considered superstition until the early 19th century. Continental drift, Alfred Wegener's theory, was ridiculed for decades until confirmed by plate tectonics. Extrasolar planets, the hypothesis of planets around other stars, remained speculation for a long time until the first was discovered in 1995. Science moves forward when someone dares to ask an uncomfortable question. And the question about 3I Atlas was exactly that. November 21st, European Southern Observatory, Chile. Very Large Telescope, VLT. 4 8-meter telescopes working in tandem or separately. One was pointed at 3I Atlas. The UVES spectrograph, ultraviolet and visual Echelle spectrograph, analyzed the comet's light with high resolution. Goal: detect rare molecules. Isotopic ratios. The deuterium to hydrogen ratio, a key parameter indicating formation conditions. In the solar system, this ratio varies depending on distance from the sun. Comets from the Oort cloud have certain values. Comets from the Kuiper belt, others. And what would an interstellar comet show? What information about a distant planetary system does it carry in its frozen body? Data came slowly. The comet was dimming every day. Spectral analysis required long exposures, several hours for one spectrum, but patience was rewarded. The DH ratio, deuterium to hydrogen, turned out close to solar system comets. This was unexpected. Did this mean that planetary system formation conditions are universal? That temperature and pressure in protoplanetary disks around different stars lead to similar isotopic distributions? Or did this indicate that 3I Atlas wasn't so different from our comets, just ejected from its system and spent billions of years in interstellar cold? Scientists built models, published preprints on Archive, argued in article comments. There was no consensus, only questions spawning new questions. November 25th, SETI Institute. Search for extraterrestrial intelligence, California. The Allen Telescope Array radio telescopes were pointed at the sky region where 3I Atlas was moving, searching for radio signals, narrowband transmissions that don't occur in nature, frequencies that could be used for interstellar communication. The hydrogen line, 21 centimeters, frequency 1,420 megahertz. Natural emission frequency of neutral hydrogen, the most abundant element in the universe. A universal channel for those who know physics, or harmonic frequencies, multiples that would stand out against cosmic noise. Observations ran around the clock. Automated data processing searched for anomalies, peaks in the spectrum, modulations resembling signals, anything different from random noise. Result? Nothing. No signals. No transmissions. Only cosmic background noise, relic radiation, synchrotron radiation from charged particles in the galaxy's magnetic fields, random bursts from pulsars and other natural sources. 3I Atlas was silent. If this was a probe, it wasn't transmitting. If this was a ship, it wasn't trying to communicate. Or perhaps it used technologies we didn't understand. Quantum entanglement for instant communication, gravitational waves, neutrino beams, or simply didn't see fit to communicate with a primitive civilization barely having ventured into near-Earth space. Or, the simplest explanation, it was just a comet, a natural object, an ice chunk carrying chemical memory of an ancient planetary system, but carrying no intelligence. Occam's razor favored the latter, the simplest explanation requiring no introduction of new entities. But Loeb didn't give up. In late November, he published an article on Medium, a platform for blogs and articles. Title: What should we look for if 3I Atlas is technology? The text was cautious but provocative. He listed signs that could indicate artificial nature. Excess thermal emission in infrared, trace of working engines or energy systems, trajectory change without apparent cause, maneuvers not explained by degassing or gravitational perturbations, deployment of smaller objects, probes, landers, subsatellites, artificial lighting, light flashes at unexpected wavelengths not matching solar reflection or gas emission, geometric structures in high-resolution images, straight lines, right angles, symmetrical patterns. None of this had been detected. Yet. December 1st. The comet moved through Virgo toward Leo. Brightness dropped to +16 magnitude. For most amateur telescopes, beyond detection capabilities. Only professional observatories and large amateur instruments with 40-centimeter diameters and larger could still see it, and even then, with difficulty, requiring hour-long exposures and careful processing. The observation window was narrowing. In a few weeks, the comet would disappear even for professionals. December 19th, last chance. Maximum approach to Earth. 1.8 astronomical units, 270 million kilometers, close by cosmic standards, but still too far to resolve nucleus structure. Angular size of the nucleus, if it really was 20 kilometers in diameter, would be about 0.5 milliarc second. For comparison, Hubble's resolution, about 50 milliarc seconds, 100 times too little. But there was another way. Interferometry, a method of combining signals from multiple telescopes separated by large distances to create a virtual telescope of enormous size. Event Horizon Telescope, a network of radio telescopes worldwide that created the first image of a black hole in 2019. Very Large Telescope VLT in VLTI interferometer mode, Atacama Large Millimeter, Submillimeter Array, ALMA. All could theoretically attempt to resolve 3I Atlas's nucleus, but this required the object to emit in suitable ranges: radio or infrared, thermal radiation from the sun-heated nucleus, radio emission from ionized gas in the coma, something that could be registered and used for interferometric measurements. Applications for observation time were submitted. Committees reviewed proposals. Competition was fierce. Each telescope received 10 times more applications than it could satisfy. December 5th, the comet crossed the boundary between Virgo and Leo, constellation Leo, one of the zodiacal constellations known since antiquity. In Mesopotamia, Egypt, Greece, the lion symbolized strength, royalty, solar power. The sun passes through Leo in late summer, the hottest period of the year in the northern hemisphere. Brightest star of the constellation, Regulus Alpha Leonis, blue-white star 79 light-years away, magnitude plus 1.3. 4 stars in the system, main component, a rapidly rotating blue-white dwarf, flattened at the poles by centrifugal force. Rotation period, less than 16 hours. Equatorial velocity, 317 kilometers per second. A bit more, and the star would tear itself apart by centrifugal forces. But it holds, shining with luminosity, 150 times solar. 3I Atlas was passing about 20 degrees west of Regulus, not close enough to use the bright star as a landmark, but enough to be in the same sky region. Leo is visible all night during winter months in the northern hemisphere, high above the horizon. Perfect observation conditions, if not for the comet's faintness. Plus 16.5 magnitude, visibility limit even for large instruments. Astronomers compiled schedules. Night of December 19th to 20th. Maximum attention, all available telescopes. Last chance to study the interstellar guest before its departure. Spectroscopy. Photometry. Search for brightness, changes indicating rotation. Measurement of velocity and direction of motion to refine orbit. Everything that could still be squeezed from the fading signal. December 10th. Avi Loeb gave another interview, a podcast dedicated to astronomy and the search for extraterrestrial life. The host asked a direct question. Do you believe 3I Atlas is an artificial object? Loeb paused, then answered, I neither believe nor disbelieve. I consider it a hypothesis requiring verification. We have data indicating anomalies. We don't have data definitively proving artificial origin. Absence of radio signals is not proof. Perhaps the object isn't transmitting or uses methods we can't detect. Absence of maneuvers is not proof. Perhaps it's a passive probe using the sun's gravity to change trajectory. Our task as scientists is to gather data and formulate conclusions based on it, not on prejudices. The host continued. But doesn't the alien probe hypothesis require extraordinary evidence? Loeb nodded, though this was an audio podcast. Yes, it does. And I'm not claiming we have such evidence. I'm saying we have intriguing data that deserves attention and further study. The problem is that many of my colleagues refuse to even consider this possibility. They a priori exclude the technology hypothesis without even testing it. This isn't science. This is dogma. Real science requires openness to all hypotheses consistent with the data and subsequent verification through additional observations and experiments. His voice was calm but firm, the voice of someone accustomed to swimming against the current. December 15th, 4 days until maximum approach. The comet was at a distance of 1.85 astronomical units from Earth. Brightness plus 16.7, continuing to dim. The coma was now barely discernible even on long exposures. Most of the gas and dust ejected during perihelion passage had dispersed. Degassing almost ceased. The nucleus had receded from the sun so far that surface temperature dropped below water ice sublimation point. Carbon dioxide could still evaporate. Its sublimation point is lower, but slowly, weakly. The comet was transitioning to dormant mode. In a few weeks, it would stop looking like a comet, would become a dark point, indistinguishable from an asteroid. Only the hyperbolic trajectory would betray its interstellar origin. Observers prepared, checked equipment, calibrated cameras, compiled lists of filters for photometry, programmed automatic telescope tracking. The comet was moving relative to stars, and the tube needed constant correction to keep the object in the field of view. Somewhere in California, an amateur with a 50-centimeter telescope planned to spend all night photographing the comet every 15 minutes to catch possible brightness changes. Somewhere in Australia, a professional observatory prepared a spectrograph for final chemical composition analysis. Somewhere in orbit, a space telescope was turning, pointing its instruments at the fading dot in Leo, final act of a drama that began on July 1st, when the Atlas telescope in Chile first noticed an unusual point in starfield images. December 19, 2025. A day marked on astronomers' calendars worldwide. Maximum approach of 3I Atlas to Earth. Distance, 267 million kilometers. 1.8 astronomical units, closer than Mars at opposition, farther than Venus at inferior conjunction. A sweet spot that gave the last opportunity to study the interstellar guest before its final departure into the abyss. Observatories had been preparing for weeks. Observation schedules were planned to the minute. Every telescope capable of registering a faint 17th magnitude object was pointed at a small patch of sky in Leo. There, among thousands of background stars, a point moved, blurred, barely discernible, but carrying mysteries that had captivated humanity from the moment the first human raised their eyes to the stars. Avi Loeb published a note on his blog the day before. The headline was provocative, as always. Will 3I Atlas bring mini-probes to Earth as Christmas gifts to humanity? The question was rhetorical, of course, but it reflected the essence of what many thought but feared to say aloud. December 19th. Just 6 days until Christmas. A symbolic date. If 3I Atlas really was a messenger from an extraterrestrial civilization, if its trajectory was planned rather than random, then maximum approach to an inhabited planet would be a logical moment for, what? Contact? Probe deployment? Transmitting a message? Loeb didn't claim this would happen. He simply asked the question. Uncomfortable. Disturbing. A question that made people either laugh or think. There was no middle ground. The fundamental question, as Loeb formulated it, was whether 3I Atlas might be a Trojan horse, an object that outwardly resembles an ordinary comet, but carries inside something completely different. The analogy was historical, the Trojan horse from ancient Greek mythology. A wooden statue left at Troy's walls as a gift to the gods. The Trojans dragged it into the city, not suspecting Greek warriors hid inside. At night they emerged, opened the gates, and Troy fell. Could an interstellar object cloaked in a cometary coma hide something active inside? Probes ready to detach at maximum approach? Technology disguised as a natural process? The idea seemed fantastical, but that's precisely why it required verification, Loeb insisted. Because if we a priori exclude a possibility, we risk missing reality when it knocks on the door. Night of December 18th to 19th, Mauna Kea Observatory in Hawaii, altitude 4,200 meters above sea level, above the clouds, air thin, cold, but incredibly transparent. One of Earth's best astronomical sights. The Subaru telescope, a Japanese 8-meter reflector, was pointed at Leo. Hyper-suprime cam, capable of covering a field of view 1.5 moons wide scanned the region where the comet should be. Exposure 300 seconds. 5 minutes of light accumulation. During this time, 3I Atlas shifted 3 arcseconds, barely noticeable displacement, but enough to distinguish a moving object from fixed background stars. The image arrived at the data processing server. Background subtraction algorithm, cosmic ray removal, moving object search. And there, in the frame's center, a blurred spot. 3I Atlas, brightness plus 17.2 magnitude, fainter than predicted. The comet was dimming faster than expected. What did this mean? Rapid fading indicated declining activity. Degassing almost ceased. The nucleus surface covered itself with a crust of refractory residues, dust, organic polymers, minerals. This crust insulated inner ice layers, preventing further evaporation, a process well known for solar system comets. Many short-period comets, those returning to the sun every few years or decades, gradually lose activity, depleting volatile substance reserves in surface layers. Eventually, they become dead comets, indistinguishable from asteroids. 3I Atlas was going through this path in a few months. One passed through the inner solar system. One activity burst, and then returned to the dormant state in which it spent billions of years in interstellar space. Spectroscopic observations continued. The Hires spectrograph on the Keck telescope, also on Mauna Kea, obtained high-resolution spectra. Goal: register the last traces of gas in the coma. Emission lines grew weaker and weaker. CO2, still noticeable, but intensity dropped tenfold compared to November measurements. Water, barely discernible. C2, diatomic carbon that created the green coma, almost disappeared. The comet stopped being green, returned to the gray, unremarkable color of dust and rock. The transformation was striking. In 5 months, from July when it was discovered to December, 3I Atlas went from a dim point through a bright green comet back to a dim point. Life cycle compressed into 1 season. Photometry showed another detail. Periodic brightness changes. Small, just a few hundredths of magnitude, but regular, period, about 8 hours. What was this? Rotation. The comet's nucleus rotated around its axis with an 8-hour period, and this rotation created weak brightness modulation, possibly due to non-spherical nucleus shape or uneven distribution of surface reflectivity. Light and dark areas alternated, creating a light curve. 8 hours per revolution. Faster than most large comets, but not abnormally fast. For an object 20 kilometers in size, such rotation speed was quite acceptable. Centrifugal force wouldn't tear the structure apart if density was at least a few hundred kilograms per cubic meter. Ice mixed with rock. Strength was sufficient. December 19th, noon Moscow time, moment of maximum approach. 3I Atlas was at minimum distance from Earth, 267 million kilometers. But for a surface observer, this was daytime, sun high in the sky. The comet somewhere there, invisible in daylight, too faint to be seen even at twilight. Only at night, when Leo rose above the eastern horizon after midnight, did observation become possible. And astronomers waited. Telescopes were ready, cameras set, spectrographs calibrated. If something unusual should happen, if Loeb was right, and 3I Atlas carried a hidden function that activated at maximum approach to an inhabited world, this would be the moment of truth. But hours passed. Midnight, 1 in the morning, 2, 3. Images arrived from telescopes, were processed, analyzed. 3I Atlas moved along its calculated trajectory. No deviations, no maneuvers. No new objects in the vicinity. Mini-probes weren't deploying. Brightness remained stable, with regular 8-hour modulation from rotation. The spectrum showed nothing new. Same weak lines of CO2, water, dust, no anomalies, no surprises. The comet simply kept flying, moving away from the sun, moving away from Earth, returning to interstellar space from which it came. Disappointment was palpable among those who hoped for something more. Relief among those who preferred simple explanations. December 20th, morning, European Southern Observatory press conference. Representatives of several astronomical groups that observed 3I Atlas over recent months gathered to present preliminary conclusions. Screens showed brightness graphs, spectra, chemical composition tables, orbital parameters. Main presenter, an astronomer from the Max Planck Institute for Astronomy, began with a brief overview. 3I Atlas is the third confirmed interstellar object to visit our solar system, discovered July 1, 2025, past perihelion October 29th at a distance of 1.36 astronomical units from the Sun. Yesterday, December 19th, reached maximum approach to Earth. The voice was even, professional. Facts, only facts. Our observations show that 3I Atlas is a natural comet. Chemical composition, though unusual, corresponds to what's expected for an object formed in a protoplanetary disk around a K or M class star. High carbon dioxide to water ratio is explained by thermal history and radiation processing during prolonged interstellar journey. Structural integrity after perihelion passage indicates a dense, sintered nucleus, which is not anomalous for large comets. Trajectory corresponds to a hyperbolic orbit with eccentricity 6.15, consistent with interstellar origin. No signs of non-gravitational acceleration that could indicate active engines were detected. Each statement was backed by data, graphs on screen, numbers in tables, rigorous methodical science. Then came questions. A journalist from a major science publication raised his hand. How do you comment on Professor Loeb's hypothesis about possible artificial nature of the object? The presenter smiled slightly. Professor Loeb is a respected scientist, and his hypotheses certainly stimulate discussion. However, our data don't support the assumption of artificial origin. All observed characteristics of 3I Atlas can be explained by natural processes. Following Occam's razor principle, we choose the explanation not requiring introduction of new entities. The answer was diplomatic but clear. Science said, "This is a comet. Natural. Unusual, yes, but still natural." Another journalist asked about the trajectory. How probable is it that a random interstellar object would be so close to the ecliptic plane and fly near several planets? The presenter nodded. This is one of the most interesting questions. Probability is indeed low. About 0.5% for orbital inclination and less for specific planetary approaches. However, it's important to remember selection bias. We detect objects that pass close to the Sun and Earth because they become brighter and easier to observe. Thousands of other interstellar objects may pass through the outer solar system every year, but we simply don't see them. Statistically rare events become observable precisely because they're rare. They approach us close enough for detection. The logic was convincing, but not for everyone. December 23rd, 3 days until Christmas. 3I Atlas was at a distance of 1.5 astronomical units from Earth, continuing to recede. Brightness dropped to plus 17.8 magnitude. For most telescopes, at the edge of detection capabilities, observations became increasingly difficult, required exposures of an hour or more. Data processing took days. The number of observatories continuing tracking reduced to a handful. Hubble Space Telescope obtained a final series of images on December 21st. Images showed a barely discernible spot shifting relative to background stars. The coma almost vanished. The object looked almost like a star, a point source surrounded only by a faint halo of scattered light. Transformation was complete. The comet again became a dormant interstellar wanderer. By late December, observations ceased completely. The comet became too faint, plus 18.5 magnitude. Even the largest telescopes barely registered its signal. Multi-hour exposures would be required to obtain even a somewhat discernible image. Scientific value of such observations was minimal. Orbit known with high precision. Chemical composition studied. Physical parameters estimated. Further observations could provide only minor refinements. The decision was made. Conclude the active research phase. 3I Atlas transitioned to cataloged object status. Entries in databases, lines in scientific papers, topics for future dissertations. But live observations ended. The comet was alone again, as it had been for billions of years before entering our system, as it would be for all the billions of years it would spend after leaving. December 31st, last day of 2025. Avi Loeb published a reflection article on his blog. Title: What did we learn from 3I Atlas? The text was philosophical. He wrote that absence of evidence for artificial origin is not evidence of absence. That natural explanation, though most probable, doesn't close the question completely. That the next interstellar object might be exactly what we've been waiting for. That science requires readiness to revise conclusions when new data appears. That the search for extraterrestrial life and technology is not fantasy, but a legitimate scientific task requiring attention and resources. And that humanity must be ready for the possibility of contact, not necessarily as a radio signal or arriving ship, but perhaps as an artifact drifting through our system. Comments under the article divided, as always. Some thanked Loeb for courage to ask uncomfortable questions. Others accused him of speculation and sensationalism. Still others simply expressed admiration, not so much for specific hypotheses, but for the very fact of interstellar travelers' existence. That somewhere out there, in the galaxy's vastness, other planetary systems exist, other comets, perhaps other worlds, and some of their fragments, or maybe messages, come to us from time to time. 3I Atlas was the third, but not the last. Oumuamua showed that interstellar objects are real. Comet Borisov confirmed they can be studied. 3I Atlas added new details to this knowledge, and the next visitor will bring new mysteries. The cycle continues. Questions spawn answers. Answers spawn new questions. This is how science moves. January 2026. 3I Atlas was over 2 astronomical units from the Sun and continuing to recede. Velocity relative to the Sun, approximately 40 kilometers per second. By year's end, it would pass Jupiter's orbit. In 10 years, Neptune, another 40,000 years, and it would leave the Oort cloud, the solar system's outer boundary. And then, interstellar space again. Endless falling through the galaxy. Perhaps in hundreds of millions of years, it will enter another star system. Perhaps there will be planets there. Perhaps on one of them there will be life. And someone will point a telescope at the sky and see a faint dot slowly shifting relative to stars. And they will ask the same questions we did. Where did it come from? What does it carry? Are we alone in the universe? Questions that unite all intelligent beings looking at the night sky. Questions without final answers. But it's in their search the meaning lies. February 2026. Institutes worldwide published papers. Data collected over 6 months of observations turned into graphs, tables, conclusions. Astronomy and astrophysics journals filled with headlines containing 3 letters and a number. 3I Atlas. Each research group told its part of the story. Spectroscopists described chemical composition, carbon dioxide dominance, traces of organics, isotopic ratios. Photometrists presented light curves, 8-hour rotation, unusually rapid dimming after perihelion. Orbital mechanics specialists refined the trajectory to meter precision, predicting the comet's position decades ahead. Each paper added a piece to the mosaic, but the complete picture remained blurred. Nature Astronomy published a review paper in March. Authors, an international team from 17 institutes, summarized the findings. 3I Atlas represents a large interstellar comet with unusual chemical composition, formed in a protoplanetary disk around a K or M-type star approximately 7 billion years ago. The object spent most of its existence in interstellar space at temperatures close to absolute zero, undergoing radiation processing by cosmic rays. Passage through the inner solar system triggered intense degassing, predominantly CO2, with subsequent rapid activity decline. The object's structural integrity after perihelion indicates a dense sintered nucleus. All observed characteristics correspond to natural origin. The conclusion was unambiguous, for most. But there were dissident voices. A small group of astrophysicists published a preprint on Archive questioning some conclusions. They pointed to the trajectory's statistical improbability. The probability of passing so close to the ecliptic plane, approaching several planets, entering the system at such an angle, all this together gave odds less than 1/10,000%. Either we observed an exceptionally rare event, the authors wrote, or the trajectory wasn't random. They didn't claim artificial origin directly. Caution required leaving the question open. But the hint was clear. Reviewers criticized the work for insufficient rigor in statistical analysis and ignoring selection effects. The paper wasn't accepted in a peer-reviewed journal, remained a preprint. Cited but not officially recognized. Loeb kept insisting. In April, he gave a major interview to Scientific American. The journalist asked, "Do you still consider it possible that 3I Atlas was a technological object?" The answer was detailed. "I believe we didn't gather enough data to exclude this possibility. Absence of radio signals proves nothing. Perhaps the object wasn't transmitting or used communication methods we don't understand. Absence of maneuvers also isn't a definitive argument. A passive probe using gravitational maneuvers would look exactly like this. Chemical composition? An artificial object could be covered with natural materials for protection or camouflage. The problem is that the scientific community demands extraordinary evidence for extraordinary claims, but simultaneously refuses to fund research that could gather this evidence. A vicious circle." His voice sounded tired. Years of debates, criticism, mockery left their mark. The Galileo project under his leadership continued its work. The team developed methods for detecting potential technological artifacts among astronomical data, machine learning algorithms trained to recognize anomalies, automatic monitoring systems for survey telescopes, specialized spectrographs for searching unusual emission lines. The goal was ambitious: create infrastructure capable of detecting the next Oumuamua or 3I Atlas at an early stage, when the object is still far away and there's time for detailed study. Funding came from private donors, scientists who shared Loeb's views but didn't want to publicly associate themselves with fringe ideas. This is how science works at the boundary of acceptability, in the twilight between accepted and rejected. May 2026. 3I Atlas was at a distance of 3.2 astronomical units from the Sun, somewhere between Mars and Jupiter orbits. Brightness dropped below 20th magnitude, completely unavailable for observations. Even the largest telescopes couldn't register its signal. Too weak, too distant, lost in detector noise. The comet vanished from humanity's view, but not from calculations. The orbit was known with high precision. Planetarium software showed its position in the sky, theoretical, invisible, but mathematically defined. A point in space receding from us at 40 kilometers per second. Every day farther, every month by millions of kilometers. Amateur astronomers kept tracking the sky region where the comet should be. Not hoping to see, that was impossible, but from a sense of connection. There, in that part of space, something moves that came from beyond everything we knew, and though eyes could no longer see it, the mind knew. It's there, forums filled with messages. Today, 3I Atlas passed Ceres's orbit. In a month, it will cross the asteroid belt. By year's end, it will reach Jupiter's distance. Virtual tracking, collective memory of an event that changed understanding. We were no longer isolated. The galaxy sends us its messengers, rarely, unpredictably, but regularly. Summer brought a documentary. A major production company made an hour-long film about 3I Atlas for a streaming service. Interviews with astronomers, computer graphics recreating the comet's journey through billions of years, telescope footage, real images of a blurred point slowly shifting among stars. Voiceover narrated the story, from formation in an ancient planetary system through endless falling in interstellar void to a brief visit to our solar system. Music was epic, visual effects impressive. Viewers left enthusiastic reviews, 5 stars. Captivating. Makes you think about our place in the universe. For most people, the film was their first introduction to 3I Atlas. The events of July-December 2025 had passed them by unnoticed. Now, 6 months later, packaged in beautiful wrapping, they became accessible. Critics in the astronomical community were less enthusiastic. Too much attention to Loeb's artificial origin theory creates the impression it's an equal hypothesis, though scientific consensus is clear. Natural object. Dramatization at the expense of accuracy. Some scenes are openly fictional, but producers knew their business. Controversial moments attracted attention, ratings grew, and with them, interest in the topic. The number of interstellar comet search queries increased tenfold. Amateur telescope sales rose. Astronomy courses at universities enrolled record numbers of students. 3I Atlas became a cultural phenomenon. Not just a scientific event, but part of public consciousness. Autumn brought news of upcoming survey programs. Vera Rubin Observatory in Chile was preparing for full launch. 8-meter mirror. Camera with 3.2 gigapixel resolution. The largest digital camera ever created for astronomy. Ability to scan the entire southern sky every 3 nights. Automatic detection of moving objects, including interstellar ones. Predictions were optimistic. Several interstellar objects per year, perhaps dozens. Oumuamua, Borisov, and 3I Atlas were just the beginning. Now, with new equipment, we'd see a flow. The galaxy is full of ejected debris from planetary systems. Trillions of comets and asteroids drifting between stars. Some pass through our system. Until now, we noticed only the brightest, closest. Soon, many more. China announced interplanetary mission plans. Not to 3I Atlas. It was already too far, but to the next interstellar guest that appears on a suitable trajectory. The concept was ambitious. A spacecraft in waiting orbit, ready to quickly change course upon target detection. Ion engines for prolonged acceleration. Autonomous navigation. A suite of instruments for analyzing composition, structure, possible radio signals. Timeline, mid-2030s. Cost, billions. But political will existed. The new century's space race included not only the Moon and Mars, but interstellar wanderers too. Whoever first sends a probe to an object from another star system will enter history. December 2026. A year passed since 3I Atlas's maximum approach to Earth. The astronomical community held an anniversary conference. Interstellar objects, year after 3I Atlas. Hundreds of presentations, thousands of participants. Topics covered everything, from orbital dynamics through chemistry to astrobiological implications. One of the most discussed questions: can interstellar comets transport life? Panspermia, the hypothesis of life spreading through space, received new momentum. If objects like 3I Atlas regularly cross planetary systems, if they carry organic molecules, if some microorganisms can survive extreme conditions of interstellar travel, then life could be a galactic phenomenon, not limited to one world or even one system. Widespread, connected by invisible threads across vast distances. Critics pointed to problems: radiation in interstellar space. Cosmic rays destroy organic molecules and DNA over millions of years. Temperatures near absolute zero stop all biological processes. The probability that a living organism survives billions of years of travel, negligible. But hypothesis defenders objected. Inside the comet, protected by layers of ice and rock, spores could be preserved. Cryptobiosis, a state of suspended life, allowed some Earth organisms to survive decades in frozen state. Why not millions of years? Why not billions? The question remained open. Required future missions. Samples delivered to Earth. Laboratory analysis. Science yet to be done. Avi Loeb attended the conference. His talk was at the end of the program. Title: Are We Ready to Meet Technology? The hall was full, partly out of respect for his reputation, partly from curiosity about what he'd say this time. Loeb began calmly. He acknowledged that data on 3I Atlas didn't confirm the artificial origin hypothesis, but, he added, this doesn't close the question in principle. The next object might be different. Our task, he said, is to create infrastructure for detecting and studying anomalies. Not to assume in advance that everything's natural, and not to assume everything's artificial. Simply look, gather data, formulate conclusions based on facts, not prejudices. Applause was polite but not enthusiastic. The community respected his courage but didn't share the enthusiasm. January 2027, 3I Atlas was already at a distance of 5 astronomical units from the Sun, beyond Jupiter's orbit. Velocity remained constant, 40 kilometers per second relative to the Sun. In 9 years, it would pass Neptune's orbit. Another 40,000 years, and it would leave the Oort cloud. And then, interstellar abyss again. Perhaps another 7 billion years of drift. Perhaps collision with a star or planet sooner. Perhaps entry into a new system, new activity burst, new observers asking the same questions, a cycle repeating infinitely. The galaxy breathes, ejects debris. Some return, others wander eternally. 3I Atlas was one of the wandering, solitary, ancient, witness to epochs we can only guess at. Planetariums worldwide showed programs about interstellar objects. Dome screens immersed viewers in space. Virtual journey with 3I Atlas, from an ancient star through emptiness to the Sun and back into darkness. The narrator's voice was measured, almost hypnotic. There, in the darkness between stars, billions of objects move. Comets, asteroids, fragments of long-dead worlds. Some as old as the galaxy. Others, young, recently ejected by forming planets. All are travelers, witnesses, connecting threads between star systems. And from time to time, one comes to us, gives us a moment of contact with an alien world, reminds us that space isn't emptiness, but living, dynamic, full of stories. We're only beginning to read these stories. 3i Atlas was one page. The next page is already on its way. We just don't know yet when it will arrive. Children in planetariums looked up, mesmerized. For them, 3i Atlas wasn't scientific data, not debates about origin. It was adventure, mystery, something that came from unimaginably distant places and touched our world for a moment. Some of these children will become astronomers, build new telescopes, send missions to the next interstellar guests. Perhaps they'll find the answer to the question that tormented Loeb and others. Are we alone? And if not, what does a message from space look like? How to recognize it if it appears? Questions passed from generation to generation, from those who discovered Oumuamua, to those who studied 3i Atlas, to those who'll meet the 4th, 5th, 100th interstellar object. Relay of knowledge, endless, like the comet's own journey through the galaxy. And somewhere there, beyond Jupiter's orbit, receding in silent darkness, it flew. 3i Atlas, the third interstellar, green comet that lost its color, mystery that received explanation, or didn't, depending on whom you ask. Messenger of 7 billion year history, witness to times when our solar system didn't yet exist. Traveler who saw, if rock can see, such expanses of space we can only dream of. It came, passed by, left, leaving us data, questions, debates, inspiration, and quiet certainty. We're not the last to look at it. In some distant system, through millions or billions of years, other eyes, or sensors, or something we can't imagine, will see the same blurred point. Ask the same questions. Feel the same trembling sense of contact with something greater, and the cycle will repeat, again and again, while stars shine, while intelligence exists capable of asking questions, while there are comets ready to cross the abyss between worlds, carrying mysteries we may never fully solve. March 2026. 5 months had passed since the last telescope on Earth lost 3i Atlas from view. The comet disappeared into darkness, becoming too faint even for the largest instruments, but space remembered it. The orbit was calculated to meter precision. Computers in planetariums displayed its position, theoretical, invisible, but mathematically irrefutable. And this position was approaching something significant: Jupiter, king of planets, a gas giant whose mass exceeds all other solar system planets combined, 11 Earth diameters wide, 318 Earth masses, a magnetic field 20,000 times stronger than Earth's. And 3i Atlas was flying straight toward it, not for collision. The trajectory passed nearby, but close enough, 53 million kilometers, closer than Earth-Mars distance at opposition. Spacecraft Juno. Juno, the ancient Roman goddess, Jupiter's wife, a NASA mission launched in 2011, arrived at the giant in 2016. Since then, in polar orbit, diving deep into radiation belts every 53 days, studying magnetic field, gravitational anomalies, internal structure. Camera JunoCam took stunning images of cloud bands, vortexes Earth-sized, lightning brighter than all Earth storms combined, polar auroras dancing at thousands of kilometers altitude. But in March 2026, Juno received a new task: temporary. Distract from Jupiter and look outward. There, where a faint dot was passing. 3i Atlas. Last chance to see it before final departure beyond reach of any observations. March 10th, closest approach, 53 million kilometers. For Jupiter's scales, nearly touching. The giant's gravitational field slightly bent the comet's trajectory. Just a bit, fractions of a degree, but enough to slightly accelerate its departure from the solar system. Gravitational assist, an effect used by space missions to gain speed. Voyager, Cassini, New Horizons, all used Jupiter's gravity to accelerate and reach outer planets or even leave the solar system. Now 3I Atlas, without planning or awareness, received similar boost. Its velocity relative to the Sun increased by several hundred meters per second. Small. But over millions of years, this meant difference of dozens of light years in final position. JunoCam was pointed at the sky region where the comet should be. The problem was that the camera wasn't designed for astronomical observations. It was created to photograph Jupiter's clouds from close range, bright, high contrast, dynamic structures, not faint dots on black background. Sensitivity was insufficient. The mission team knew this, but the attempt was worth it. They programmed a series of long exposures, 30 seconds per frame, 100 frames in succession. Image stacking, a method that worked for amateurs on Earth, might work here too. Data began arriving on Earth within hours. Transmission speed from Jupiter is low, distance enormous. Processing took days. Engineers and scientists stacked frames, subtracted background, searched for weak signal amid noise. And there, in the corner of the stacked image, a speck, barely discernible, but statistically significant. Not random noise, not a cosmic ray, not a background star, checked against catalogs. The object moved at velocity consistent with 3I Atlas's calculated trajectory. It was her. Last direct observation of the interstellar guest. Pixels on screen, a few photons that traversed hundreds of millions of kilometers, collected by a spacecraft detector, digitized, transmitted through void, deciphered, processed, and became proof. The comet is still there, continues its path, relentlessly, silently, receding into abyss. Brightness in the Juno image corresponded to approximately 21st magnitude, the absolute limit of camera capabilities. Beyond, nothing. No Earth observatory could register an object so faint at such distance. Even the James Webb Space Telescope, most powerful existing, would require many-hour exposures for detection. And this held no scientific value. Orbit known, composition studied, physical parameters estimated. Further observations would provide only confirmation of what's already known. The decision was made. Conclude all observation programs for 3I Atlas. The object transitioned to historical category. Those remembered, studied from archive data, but no longer actively observed. The scientific community drew final conclusions. By summer 2026, over 200 scientific papers about 3I Atlas were published. Spectroscopy, photometry, orbital mechanics, chemical composition, comparison with Oumuamua and Comet Borisov, models of interstellar object formation, statistics of such objects entering the solar system. Each paper cited dozens of others, a bibliography forming that would become foundation for future research. Students wrote dissertations. Professors obtained grants to continue work. Slow, methodical machine of science ground through data, extracting knowledge grain by grain. Consensus formed. 3I Atlas is a natural comet of interstellar origin. Unusual, yes. Anomalous in some aspects, certainly. But explainable by natural processes without needing artificial origin hypothesis. Most astronomers agreed with this conclusion. Not all. A small group kept pointing to statistical inconsistencies, too precise trajectory, too many coincidences. But these were minority voices. Science moves by consensus, and consensus said, nature. Loeb accepted this with characteristic mix of disappointment and stubbornness. Absence of evidence is not evidence of absence, he repeated in interviews. The next object might be exactly what we're looking for. And 3I Atlas, meanwhile, continued receding. By late 2026, it was over 6 astronomical units from the Sun. Beyond Jupiter's orbit, surface temperature of nucleus dropped to minus 200 degrees Celsius. All degassing ceased. Water, carbon dioxide, carbon monoxide, all froze into monolithic block. The comet became an asteroid, dark, inert, dead. Only its hyperbolic trajectory betrayed its unusual nature. In 9 years, it would pass Neptune's orbit. In 30, reach the Kuiper belt. Another 10,000 years, the heliopause, boundary where solar wind meets interstellar medium, and then true interstellar space. Again, as it had been for billions of years before. Space museums added exhibits about 3I Atlas, comet models, recreated from observation data, interactive screens showing trajectory through the solar system, video clips with frame-by-frame animation of movement among stars. Children touched screens, launched simulations, asked tour guides questions. Where did it come from? From a red dwarf system, maybe hundreds of light years away. Will it come back? No, never. Its orbit is hyperbolic. It passes once and leaves forever. Is there life where it came from? We don't know. Maybe. Maybe there's someone looks at their sky and sees another comet from another system. Maybe they ask the same questions we do. School astronomy textbooks updated. New chapter. Interstellar objects. Oumuamua opened the topic. Comet Borisov confirmed this wasn't isolated. 3I Atlas added details. Now students knew the galaxy is full of wanderers, debris from destroyed planetary systems, comets ejected by gas giants' gravity, asteroids knocked loose by collisions, all drifting in void between stars. Sometimes something enters our system. We see, study, learn. Each such visit, a lesson about chemistry of distant worlds, about planetary formation processes, about galactic dynamics, about our place in space. Avi Loeb's Galileo project received additional funding. Despite majority skepticism, there were those who believed in importance of systematic search for technological artifacts. Private donors, mostly from Silicon Valley, billionaires who made fortunes in technology and dreamed of next big discovery. They allocated tens of millions. Network of automatic telescopes was built. Machine learning algorithms developed for detecting anomalies in massive data. Infrastructure prepared for rapid response to next interstellar object discovery. Goal: obtain data at early stage when object still far, bright, accessible for detailed study. Don't miss chance as happened with Oumuamua, discovered already on system exit. Vera Rubin Observatory began full operations in late 2026. 8-meter telescope in Chile, 3 billion pixel camera, survey of entire southern sky every 3 nights. First months exceeded all expectations. Thousands of new asteroids, hundreds of comets, transients, variable objects flashing and fading, supernovae in distant galaxies, merging black holes, and yes, first interstellar object detected by new system. Not as bright as 3I Atlas, not as massive as Oumuamua, but fourth confirmed. 4I. Designation not yet assigned. Observations continue. But fact stands. They come regularly. We simply didn't have instruments before to detect them. Statistics refined. New estimates. One interstellar object larger than 100 meters passes through inner solar system roughly once per year. Most remain undetected, too faint, too fast, pass too far from sun. But some, bright, close, accessible for study. With new telescopes, we began seeing them. Next decade promised discovery of dozens of interstellar objects, each unique story, each chemical fingerprint of distant planetary system, each opportunity to learn something new about galaxy. Philosophers and writers reflected on these discoveries' significance. Interstellar objects erased boundaries. Solar system ceased being isolated island. It was part of flow, material exchanged between systems. Comets, asteroids, dust, all traveled. Possibly life too. Panspermia from hypothesis became serious scientific theory. Microorganisms protected by ice depth within comet could theoretically survive interstellar journey. Upon entering new system, upon heating, upon melting, they could be released, reach planet, start new life, or die in alien environment. We didn't know, but possibility existed, and it changed understanding of life's origin. Perhaps life on Earth didn't arise here. Perhaps it arrived on Comet, billions of years ago. Religious thinkers also responded. For some, interstellar wanderers proved creation's grandeur. God created not just the solar system, but countless others, and linked them by invisible threads. Comets, messengers reminding of cosmos's unity. For others, this challenged anthropocentrism. Humanity, not universe's center. Earth, one of countless planets. Life perhaps widespread. Intelligence, possibly too. Our role, not to rule but to learn. Humbly accept information cosmic guests bring, each tradition interpreted differently. But all agreed, this matters. This changes something fundamental in our understanding of humanity's place. Year 2027. 2 years passed since 3I Atlas discovery. The comet was already 7 astronomical units away, between Jupiter and Saturn orbits, absolutely invisible, but present in calculations, databases, memory. Astronomers continued updating its ephemerides, position tables for future. In 100 years, it will be there. In 1,000, there. In million. In certain galactic sector, within margin of several light years. Accuracy declined with increasing time interval. Gravitational perturbations from invisible stars, passage through molecular clouds, random collisions with interstellar gas, all accumulated. Over billion years, 3I Atlas position predictable only within galactic sector thousands of light years across. But it will be there, somewhere. Continuing fall through void. 3I Atlas's legacy was multifaceted. Scientific data, hundreds of papers, thousands of citations, new observation methods, improved models of comet chemical evolution, refined estimates of interstellar visit frequency. But there was something more. Cultural influence. The comet became symbol. Symbol of connection between stars. Symbol that cosmos isn't dead and empty. Symbol of questions we don't yet answer. Films, books, songs, paintings. Artists interpreted the theme their own way. Some saw loneliness, comet forever wandering, never finding home. Others, hope, messenger proving that beyond our world there's something else. Still others, mystery, object we saw but didn't fully understand. Each interpretation added layer to myth forming around 3I Atlas, and somewhere there, in cold darkness between Jupiter and Saturn, flew object. 20 kilometers of rock and ice, covered by crust of radiation-processed materials, holding in depths chemical memory of star that shone when our sun wasn't yet born. Silent, cold, inert, but carrying 7 billion year history of journey through galaxy, history we read only partially, and that will continue billions of years after our civilization perhaps vanishes. Because comets live longer than civilizations, stars live longer than intelligence, universe lives longer than everything. And in this universe, 3I Atlas was just dust particle, but particle that for a moment by cosmic standards crossed our lives and left trace in data, in memory, in questions we'll keep asking, looking at night sky. Year 2028. 3 years passed since perihelion. 3I Atlas was at a distance of 9 astronomical units from the Sun, beyond Saturn's orbit, too far to imagine without numbers and graphs. For an earthbound human, infinity, it was no longer subject of active scientific study. Archive data was analyzed, reanalyzed, interpreted anew. Each generation of young astronomers found something of their own in collected materials. New approaches, new methods, old data from new angles yielded new answers. Science, like a living organism, continued feeding on the past, extracting nutrients for growth. First master's dissertation entirely devoted to 3I Atlas was defended in 2028 at Harvard. A student born a year before the comet's discovery grew up with news of the interstellar guest. For her generation, this was normal. Objects from other star systems existed, were ordinary. She studied all available data, combined it with new observations of the 4th interstellar object discovered years earlier, and proposed new model. By her calculations, 3I Atlas formed not around a K-type star as previously thought, but around much colder M-type red dwarf. New chemical modeling, computer simulation of protoplanetary disk calculated with computing power unavailable 2 years prior. Results force textbooks rewritten. Again. Her advisor was one of those who worked with Avi Loeb. By this time, Loeb had status of scientific heretic, as called in academic circles, but respected heretic. His ideas, though rejected by majority, stimulated methodology development, because science that doesn't allow itself to be wrong inevitably stagnates. We need voices saying, "What if you're wrong?" Even if these voices often are wrong, especially because they often are. Mistakes are fuel that drives science. By late 2028, published papers about 3I Atlas reached 370, 500 authors, thousands of citations. The object ceased being just a comet. It became symbol of new astronomy era when we understood solar system isn't isolated, it's part of flow, galactic bloodstream where debris from various worlds circulates. Each passing interstellar object is messenger from distant past, from stars that might already have died, from planetary systems that could have been destroyed, from utterly alien worlds we'll never know anything about except chemical composition of their rocky fragments. Philosophy changes. Anthropocentrism loses grip. Earth still seemed special. Life here, intelligence, history. But it no longer seemed universe's center. It was one of trillions of planets. Its sun, one of 200 billion stars only in our galaxy. The galaxy itself, one of trillions in visible universe. Scales crushing, leading to philosophical crisis or philosophical awakening, depending on person. Some saw horror. If we're so insignificant, then nothing matters. Others saw liberation. If we're not center, we're free. Free to be simply part of something bigger. Free to learn. Dissolve into cosmos, as ancient philosophy said. Culture absorbed 3I Atlas deeper than expected. Films, music, literature. A Japanese director made science fiction film about first contact with interstellar object. Not 3I Atlas specifically, but inspired by its story. A Nigerian musician wrote song about Lonely Comet, a Norwegian writer, novel about civilization that built cosmic probe and launched it into interstellar space where it drifts, hoping to someday meet other intelligence. All these creations shared one theme: solitude and search. Search for home, search for meaning, search for answer. Is anyone else out there? Religion responded too. Catholic Church published documents speaking of divine connection between all worlds. Buddhist temples conducted meditations contemplating journey of samsara, each universe object travels. Muslim scholars quoted Quran speaking of revelations coming from afar. Each tradition found reflection of its own truths in Three-Eye Atlas. Because great scientific discoveries like great works of art function as mirrors, people see in them what they already know, but didn't dare say aloud. Year 2029, 4 years. Comet at distance 11 astronomical units, far beyond Saturn's orbit, its position still calculated by astronomers for catalogs, textbooks, but real scientific value exhausted. No more data will come. Only memories. Only reinterpretation of what we already know. Only speculation about what its existence means. For history? For future? For intelligence trying to understand its place? The Harvard Institute published collection of selected papers about Three-Eye Atlas, editors, same people who worked with Loeb. Introduction written by Loeb himself was reflective, almost confessional. "We may not find evidence of technology," he wrote, "but we found something greater. We found question that transforms science. Because real science isn't in answers, it's in questions we dare ask. Three-Eye Atlas gave us right to ask, and regardless of whether it's natural or artificial, its legacy, the legacy of question never fully answered, because every answer births new questions, and cycle continues. It flew, still flew, at distances exceeding human imagination, in directions soon impossible to track. In 100 years, its position will be known within galactic sector thousands of light years across. In thousand, within entire galactic spiral. In million, somewhere in Milky Way vicinity. In billion, unknown. Probably somewhere in other galaxy, ejected by gravitational interaction or collision. Or perhaps fallen into black hole, or collided with star. Various endings possible. But journey continues. Because in universe, there's no rest. Only movement. Only journey. Only echo of past spreading into future. And people very far from here, in some other worlds, probably other galaxies, possibly even other physics dimensions we haven't understood yet. These people, or beings, or intelligences, whatever form they take, probably also look at sky, and probably they see their comets, their interstellar guests, their questions, and they ask themselves same question we do. Are they alone? What does this traveling past carry? Where did it come from? Where does it go? And if we both look at night sky asking same thing, aren't we already somehow connected? Isn't this form of contact? Not through radio waves or ships, but through shared questions carried by comets through billions of years? Three-Eye Atlas never returned. Its orbit was hyperbolic, definitively. No return. Eternal journey. But in memory, it remained, in data that generations will analyze. In questions it raised. In dispute between Loeb and scientific consensus. Dispute never fully concluded because both were, in their way, right. Nature can be wondrous without artificial help, but artificiality also deserves consideration, and boundary between them, not clear line, but blurred cloud of probabilities. And exactly in this cloud lives science, lives truth, lives future, year 2035, 10 years past. Three-Eye Atlas was at a distance of 27 astronomical units from the Sun, between Neptune's orbit and the Kuiper Belt. Its name long since became historical. In textbooks, it figured as third interstellar object, in archives, as historical artifact. But for few astronomers continuing to track archive data, it remained alive. Its trajectory still calculated with same precision, its position marked in catalogs, its history retold to students who might someday discover next interstellar objects. Science, like living organism, continued feeding on past. Vera Rubin Observatory discovered the 100th interstellar object. In 10 years since 3I Atlas discovery frequency increased exponentially. First 3 objects separated by years: Oumuamua in 2017, Borisov in 2019, 3I Atlas in 2025. But then, with observational technology improvements, everything accelerated. By 2033, 50 interstellar objects per year were discovered. By 2035, far more. A flow, galactic bloodstream circulating through our system became visible. Trillions of comets and asteroids traveling between stars. We saw only small fraction. But now we knew they were there. Everywhere. Constantly. Avi Loeb in 2035 was elderly, hair completely gray, back bent from decades working over computers. But mind remained sharp. His blog devoted to searching for extraterrestrial technology, read by thousands. Galileo Project became international consortium. Universities worldwide conducted courses detecting potential technological artifacts in astronomical data. Students wrote dissertations on 3I Atlas. Professors cited his work, approvingly or critically, but cited it. His persistence in asking uncomfortable questions changed paradigm. Now, search for extraterrestrial technology sounded serious, sounded scientific. Though consensus remained skeptical, door was open. Crack through which alternative hypothesis could seep. And this was achievement. In 2035, China successfully launched its interplanetary probe. Not to study 3I Atlas, it was too far, but to intercept 14th interstellar object discovered years ago on suitable trajectory. First mission in history targeting interstellar body. Development took 15 years. Now, as probe approached target, whole world watched. Not just scientists, politicians, journalists, ordinary people. Because 3I Atlas taught humanity something. What comes from beyond matters, can change understanding, can be important, and China's probe flew there to learn what next messenger carries. Young astronomer from Nigeria, born 2 years after 3I Atlas discovery, defended doctoral dissertation entirely devoted to this comet. New method for analyzing archive data, new software for detecting artificiality signatures, new conclusions about chemical composition. Her work published in Nature Astronomy, one of most prestigious journals. 30 years of life not passed, yet 3I Atlas continued inspiring new researchers. This was its legacy, not answers, because no final answers existed, but questions. Questions spawning new research, new methods, new understandings. Questions living longer than object that raised them. Night into 2036, New Year's night. Moscow Planetarium conducted special show devoted to decade of 3I Atlas. Climax, virtual journey through solar system, merging real observation data with computer graphics. 3I Atlas image not precise in details. Nobody saw nucleus close enough. But essence was correct. Small black world, covered by crust of radiation-processed materials, carrying within itself secrets of 7 billion years traveling. Viewers looked up at dome screen and saw a comet passing the sun, saw its glint in solar radiance, saw its emergence in night sky, saw its departure into darkness. Each viewer felt same awe. Scientists felt discovering point of light on telescope images. That feeling we're not alone. That cosmos full of stories. That some of these stories come home to us, briefly letting us touch something greater. Science historians wrote papers. 3I Atlas and paradigm shift in 21st century astronomy. From Oumuamua to 3I Atlas, evolution of our understanding interstellar objects. Avi Loeb and culture of skepticism in scientific community. Each paper attempted to comprehend significance. What changed because of this comet? To be honest, scientific conclusions were modest. It was a comet, probably natural origin. Its chemical composition, slightly unusual but explainable. Its orbit, rare but not impossible. Everything fit within known science. Yet simultaneously, everything changed because it asked a question that proved more painful, sharper, significant than seemed. Question about nature of artificiality, about boundary between nature and technology, about how to know difference if it comes from far away. 3 billion kilometers, 300 light seconds from the sun. 3I Atlas continued receding. Its velocity relative to sun remained constant, 40 kilometers per second. Over several centuries it would pass Oort cloud. Over several thousands of years it would leave our star's gravitational influence. Become truly interstellar, free. One of billions of comets drifting in cold emptiness between stars. Nobody would observe it anymore, maybe by chance, if it accidentally passed near some human probe still functioning. But likely, nobody. It would return to anonymity, to silence that lasted billions of years before entering our system. And this was good, because if it's important to humanity, not because it remains observable, but because it was bright enough, close enough, long enough that we could study it, ask it questions, hear its silent answers, measure it, analyze it, and through this measurement and analysis, obtain piece of knowledge about cosmos, about how it's structured, about what it contains, about our place in it. 3I Atlas was messenger, not in sense Loeb suggested, though that too was possible, but in sense cleaner, more fundamental. Messenger from old cosmos to young humanity. Sample from ancient worlds to our young consciousness. Reminder that universe contains history far older than ours. And if we listen, if we observe, if we're not afraid to ask questions, this history can become our history, can teach us, can transform us. By 2050, no more conclusions expected. Data on 3I Atlas considered complete. Few new papers perhaps, reinterpretations of archive observations in light of new theories, but nothing fundamentally new. Comet passed, leaving legacy, not sensational, but significant, in form of hundreds of scientific papers, in form of inspiration for young scientists, in form of changed understanding of solar system, and perhaps most importantly, in form of changed attitude toward possibility. That some questions deserve consideration even if answers frighten us, even if majority agrees with different answer, even if answer could overturn everything we knew. Questions are first step to truth, and 3I Atlas taught us not to fear asking questions. Somewhere in darkness between stars, at distance exceeding imagination, it flew, small, ancient, silent, but carrying within itself history, carrying questions, carrying echo of other worlds, and one day, through millions or billions of years, it perhaps would enter another system, meet other intelligence, other telescopes, other questions, and cycle would repeat, again, forever, while stars shine, while intelligence exists capable of looking up, and while comets drift between worlds, carrying messages from past days to days future. 3I Atlas completed its visit to our system, but its echo remained, will sound longer than it flew, will inspire longer than it was visible, will teach longer than we'll live, because some messages have no end. They simply repeat, transforming, evolving, eternally, like universe itself.